Hello everyone, this is Mr. Ahmed Faidi on Art Farouk Language School, and now we'll start a new video in geometry, vectors, and today inshallah we'll explain polar form and some of the fundamental unit vectors. So let's start with the definition of polar form of position vector. So we have OA is position vector, OA of the point x and y and makes with the positive direction of x-axis a positive angle of measure theta. So now theta is called polar angle and theta belongs to 0 degree closed and 360 open. So theta may be in first quadrant or second quadrant or third quadrant or in fourth quadrant. So now we'll use a new form called polar form, and it consists of the norm of the position vector OA and the theta, the angle theta, which you make with the positive direction of x-axis. And this form is called the polar form of the position vector OA, which is equal to the Cartesian ordered pair x and y. So OA, the position vector, can be write as ordered pair x and y, or we can write it as new form, which is called the polar form, by using the norm and the measure of the angle which you make with the positive direction of x-axis. So we can write it as the norm of OA and the angle theta. So theta is called the polar angle, as we said before, and theta belongs to 0 closed and 360 open. So theta may be draw the angle in first quadrant or in y-axis or in second quadrant or third quadrant or fourth quadrant. So theta have many values belong to 0 closed and 360 open. So polar form of the position vector. The position vector OA of the point x and y makes with the positive direction of x-axis a positive angle of measure theta. So we say before OA equal xy equal the norm of OA and the angle theta, which is in polar form. So we have this part is called x and this part is called y. So we have cosine theta equal x, which is adjacent over hypotenuse over norm A. So if you want to find x coordinate of the position vector OA, so we make cross multiplication, so x equal norm A cosine theta. So this part will be norm A cosine theta, and we have sine theta equal y over norm of the vector A. So if you want y, so we'll make cross multiplication, so y equal norm of vector A multiplied by sine theta, so y coordinate equal norm of vector A multiplied by sine theta. And this is important note. If we want to find the x, which is adjacent, so will be norm of the vector A multiplied cosine theta. And if you want to find y, which is the opposite to angle theta, will be norm of A multiplied by sine theta. The coordinate of the point A in the orthogonal coordinate plane are x equal norm A multiply cosine theta and y equal norm A sine theta. And if you want to find the measure of angle theta, so we can use the rule tan theta equal y over x. So we can find the measure of the angle theta. Okay, we have an example. In the orthogonal coordinate plane, if A is 6 and 6 root 3, find the polar form of the position vector of point A with respect to the origin point O. So we have theta, which make with the positive direction of x-axis, and this part is called x, or the adjacent, and opposite will be y. So if you want to find the coordinate of x, we have, at first we will find the norm of OA, which is mean length of OA, which is equal 6, as we said before in last videos. If you want to find the norm, we have rule, which mean x power 2 plus y power 2, 6 power 2 plus 6 root 3 all power 2, under square root, which is equal to 12. So the norm is 12. If you want to find tan theta, if you want to find tan theta, so it's mean y over x, opposite over adjacent, 6 root 3 over 6. So we can find the acute angle which theta make with the positive direction of x-axis. So theta belong to the first quadrant. We can use shift tan root 3 by using calculator. So the angle is 60 degree. In polar form or in radian measure will be pi over 3. So OA in the polar form, the vector or the directed line segment OA equal 12, which is the norm, and the angle which is pi over 3, ordered where 12 and pi over 3. So try to solve. If O is OC equal 12 root 2 and 3 pi over 4, so it's written in the polar form, is position vector of the point C with respect to the origin point O. Find the coordinate of the point C. We want to find the coordinate of the point C. So we say before, x coordinate equal norm C multiply cosine the angle theta. So x equal 12 root 2 multiply cosine the angle 3 pi over 4, and we substitute by 180. So x equal negative 12, and if you want to find y coordinate, so we can use the rule, which is norm of A multiply sine theta. So 12 root 2 multiply sine 3 pi over 4, which is equal to 12. So the coordinate of C will be negative 12 and 12. Unit vector, the unit vector is a vector whose norm is unity. As we said before, unit vector is a vector whose norm is unity. And now we'll study a new shape or new form for the vector, which is called fundamental unit vectors. Fundamental unit vectors. We express the unit vector by the unity vector, so we want to find the fundamental unit vector. So we have x-axis and represented by I, the unity vector in x-axis. We have its in Cartesian will be 1 ordered where 1 and 0. In Cartesian coordinate 1 and 0. So in fundamental form will be 1 and 0 equal to the vector I, and the fundamental unit vector I, it is the directed line segment with starting point to the origin point, and its norm is the unity, and its direction is the positive direction of x-axis. It's important we have a direction. We have a direction which is the positive direction of x-axis. So if you want to express the unity vector in y-axis, so the fundamental unit vector is represented by j vector. It is the directed line segment with starting point to the origin point, and its norm is unity also, and the direction is the positive direction of y-axis. So we have I, so I in x-axis, it's mean 1 and 0. I vector, it's mean 1 and 0, and j vector, it's mean 0 and 1, because we take the positive direction of x-axis and the positive direction of y-axis. So if m equal x and y, so we can write the vector m by x and 0 and 0 and y by addition property. So from definition of addition, x and y ordered pair x and y, it's mean x and 0 ordered pair x and 0 plus ordered pair 0 and y. So we can write x and 0 as a unity vector, x multiplied